Um, Good morning, everyone, and welcome to this session on the 3-day conclave for GATE and ESP aspirants. And I thank the organizers for inviting me to give this presentation. And so I'm going to talk about my journey in terms of finding AI and getting to work, and also all the mentors and experiences I've had along the way. I'm Dr. B Ravindran. I'm a faculty at IIT Madras, and I also head the Robert Bosch Centre for Data Science and AI. That's a research center at IIT Madras. Yeah. Okay. I'm still getting used to the interface. So if I suddenly stop and search around for some button on the interface, so please bear with me. So to start off, right? So all of us know that AI is hot. Right? So everybody talks about AI now, right? And all of us use AI whenever we run a Google search. We are using AI, and whenever we go to Facebook, all these things that pop up telling you to mark a face, or suggesting friends for you, and so on and so forth. Events that you can attend. All of these use some kind of AI technology. Let's not get to what AI is now. I'm not going to talk about that. But then not just frivolous things like ordering food or buying things online, but also more important things like like in medical diagnosis, discovering breast cancers, or looking at chest X-rays and trying to detect any abnormalities and so on and so forth. So AI is helping us in a variety of ways, not just in daily life, but also in more important things. And soon you would come to a point where every phase of life, be it what classes to take in school versus whether you're going to get a loan or not, everything is going to be filtered through some lens of AI. Right? So, but AI is not just hot now, right? Back when I was in school, one of the first things that attracted me to AI was the connection of AI and chess. So I thought I'll talk a little bit about it. Right? Back in like 89, so a large fraction of the audience now would probably not have been born then. And back in 89, there was this program called Dept. This is creating a lot of it's actually slightly earlier than 89, maybe 87, 88. A lot of noise was being created about this computer that was getting so good that it was beating uh, uh, chess grandmasters. So back then, a lot of us were crazy about chess because there was one place where we had a true world champion. I mean, he yet to become the world champion, but was competitive at the world level. So we had Vishwanathan Anand. And so all of us were really excited about chess for nothing else, just for patriotic reasons. And so then this deep thought came in, and then defeated several grandmasters in chess, and then it came to Kasparov, and it lost. It was a really very highly publicized match. A lot of people, even in India, were following that very closely, right? But then in 1994, something interesting happened. There was a chess engine, it's called ChessGenius, which actually beat Kasparov, but then lost to Anand in a rapid chess match. So for maybe some of the older people who are listening there, that was a very nice moment for Indians because Anand had never beaten Kasparov. He'll always come to the top and then keep losing to Kasparov. And at least this was a way of vicariously for him to beat Kasparov. He beat a computer that beat Kasparov. So he was feeling a little happy about it. And then things went on, right? And then 96, there was this computer called Deep Blue, which again came up with a lot of noise, and IBM had released this. But it lost to Kasparov. But then it came back in 97 and it defeated Kasparov. And that was the first time ever a computer had beat a chess world champion in regular match play. All the other cases where they were all with weird time controls and things like that. That was the first time that something beat a real in real match play. And since then, computer chess has become really strong, right? So nowadays, it's very hard for even the best grandmasters to win against the computers on a regular basis. In fact, they play handicap chess, where the computer gets a handicap now. But then going back in history, back in 80s, like late 80s, when I started getting interested in AI. Right. So in some sense, my AI journey started in school. So this was the place I went to school, St. Beach, and St. Beach is actually for guys who are from Chennai, you should know that as a very famous cricket school. More than academics, it's very popularly known for cricket, and several St. Beach graduates have gone on to represent India as well. Then I started my journey into AI by picking up this book, right? So this book written by Len Rich on AI. This book itself was published in like '88, right? And so at that time it was like cutting edge, and we managed to get a copy of it somehow shipped to us from Singapore. It was not even available in India back then. And so then I started reading this book, and then I was getting really excited about it, right? And it was it's somewhat serendipitous. And at the time, I was also very interested in computers, so everything came together, and we started writing simple programs and things like that. Then my journey continued in college, right? So I went to this Tiagarajar College of Engineering in Madurai, and it's a great place. I mean, I really, I mean, as with many people who had aspirations for higher studies in academia and things like that, I was trying to get into IITs. It didn't happen, but then I'm glad that I ended up here because it was a whole different set of experiences that we got at this college as well. Right? In fact, this one of those places that are undergoing a great transformation. Now it's 60 years old, and it's been doing really well. But what happened? Well, right, I was really interested at this point of time. My interest in AI had kind of morphed to really understanding about how the human mind works, how the human mind learns, right, and whether we are beginning to get computers to learn like that. And it turns out that the original motivation for the field of AI was also this, right? Can we systematize the whole process of thinking and decision making so that the computers can simulate it and not just humans? That's how the whole field got started, right? And so I started wanting to learn about how the human mind works. And of course, just like now, back then in the '80s and like early '90s, neural networks were very hot, right? And so I believed, like everyone, that neural networks were the way that human mind is going to work. And I wanted to learn more about it. But really, there were no courses on neural networks that were being taught. Maybe they were being taught in some of the IITs and places, but not in Tiagarajar College. But then I managed to find one faculty member who had a photocopied version of this book. I mean, this book is no longer popular. It is very dated, but back then it was an eye opener for me. That's Neural Computing Theory and Practice by Wasserman. And I managed to get a photocopied version of the book from a faculty member and photocopied it. I mean, so back then, there was so much control, and it's very hard to get books into India. So so this was a common practice, right? I wanted to learn more about how this whole thing happened. But I soon realized that neural networks, even as the way it was described in Wasserman, there's like this one chapter where they talk about how biological neurons and they fire this and that. And then I realized that it was essentially a collection of methods, right, for fitting complex functions using various optimization techniques, right? And the later on the exposure I got during my masters in IIC kind of reinforced this opinion that it was more and more about complex functions and optimization technique and less about biology. I was a little disappointed, but I still wanted to continue learning. And then I moved on to my next milestone, which several of you have either gone through or planning to go through very quickly, which is get ready for GATE, right? So I did prepare, and not a whole lot because a lot of my preparation was done during classes itself. But then I wrote GATE, I did well. And but then I didn't choose to go through the regular MTech or ME route, but I entered the MSc engineering program at University of Science, Bangalore. It's a kind of a unique research program back then. It's a master's research program. And back then, we didn't have too many of those in India. Right now, almost all the IITs and several other institutes or IIITs offer a master's research program. Back then, there were like very few options if you wanted to do master's research. So either like you had to go to IISc, I think IIT Madras had one back then, right? Then we moved. Then I started working at doing the research program there. So that is a very unique experience, right? So this is very different from a very structured master's program where you just do courses. You do courses and then you do a project which a guide assigns to you. A very well structured, well defined project. You do that. You run some experiments, show some results, and then you graduate. So the master's research program, the MSc engineering program as it was called back then, is a little bit more unstructured. Right? So it's not like you know exactly what you need to do to get out. So you are free to explore. Right? You can do a lot of things. But also there's a downside. It took me 2.5 years to complete the program, while the MBA program was taking 1.5 years back then. But then I learned a lot, right? It was an amazing period of time. And so I went to IISc. It's a great campus in the first place, and it's got a very unique research culture. And then I started monkeying around. So what do I mean by that? Remember, I was interested in figuring out how humans learn, right? So at the neural networks was more from a structural perspective. How the brain is wired up. Can we look at physical components in the brain and try to imitate them and learn? And that was going nowhere, at least according to my readings at back then, right? And of course, yeah, that's not a completely accurate picture, but that's what I felt at that point. So then I started looking at more literature on behavioral modeling, right? How does, hey, maybe we don't want to really look at the neural level, but can we look at the behavioral level? So then I came across this set of literature on trying to model, like computationally model how things like monkeys learning, right? So here was a task where the monkey was supposed to press a light when a particular press a switch when a particular light comes on, and the monkey gets rewarded by like a drop of juice, and then if it did the right thing, right? And it turned out that this is amazing for me, right? So it turned out that there were these computational models called temporal difference learning that could actually mimic how a particular neurotransmitter in the brain called dopamine behaved, right? And so this was really an eye opener for me. Saying, hey, look, somebody is making measurements in the brain, like looking at the behavior of how various things work, and then they are trying to fit it to a computational model, and then they have succeeded. So maybe this is the right direction to look at, right? And that field was what we call reinforcement learning, right? So essentially, reinforcement learning is a trial and error learning model. Right? You basically learn from rewards and punishments. In the case of the monkey, it was getting rewarded by the juice, right? And you learn about the system through interaction. So the monkey is actually doing reinforcement learning. But basically interacting by pressing the button, looking at the lights and stuff like that. And it is significantly inspired by behavioral psychology. And the roots of it were not in the 90s or the 80s. It goes even further back. Some of you might have heard of the Pavlov's dog experiment, where the dog learns to salivate at the sound of a bell, even though it has normally it does salivates on the sight of food, right? So when you ring a bell, the dog doesn't. I mean, if the bell is very loud, the dog might bark, but it's not going to salivate, right? But then what Pavlov did was it conditioned the dog by presenting food and the bell together for many times, and then after a while, when you ring the bell, the dog starts salivating. So what it has learned is it has learned about the system. Oh, the bell means that there is food coming, right? And then it learns to predict the reward that is going to come. So this is kind of predictive models that animals built, and by generalization, humans who are animals build, right? So this is kind of very simple behavioral psychology experiments, and the roots of reinforcement learning go back to that. Right. And so it's not just dogs. I mean, it's like humans, how we learn. So always I kind of motivate what reinforcement learning is by asking the question, how did you learn to cycle? Right? If I had given you like 1,000 hours of YouTube videos of people cycling and then give you a cycle, can you get on it and learn to cycle? Right? Not really, right? So you have to actually get on the cycle, try a few things, fall down, get hurt, or have your parent or uncle or aunt somewhere and clap and say, yeah, good boy. That's the way to do it, or something, right? Only then you learn. So you need some kind of feedback, right? You have a trial and error process, right? And so the reinforcement learning is all about getting a mathematical formalism for this kind of a trial and error learning process. Okay? And it's not just for cycling. I mean, if you go back and think about how babies learn to walk, talk, all of this comes from reinforcement learning. Right? So this kind of trial and error. Babies first start babbling, and then they might accidentally say mama or papa or something like that. And all the adults around the baby will go crazy. Oh yeah, he said mama. And then the baby goes, oh yeah, maybe I should repeat that more often. So that's the kind of feedback process that causes us to learn in many cases. And but all this learning on reinforcement learning was facilitated because I had a tremendous mentor. Right? This is Professor Satyakirti. This is more or less how we look back then. Okay, now all of us look much older. Satyakirti was not a person in reinforcement learning. In fact, he was very well known in optimization, and then later on, after my time with him, he became one of the top researchers in kernel methods around the world. But at that time, he said, "Okay, you want to learn about reinforcement learning? Go ahead." And then not only did he give me the freedom to explore, he learned reinforcement learning along, right? And kind of was a true guide and a true mentor. And together we ended up writing a very widely read tutorial survey on reinforcement learning. In fact, in some sense, that was my qualifying mark for getting into a PhD program as well. But apart from that, I did other work on during my master's, but it was largely facilitated and driven, motivated by specificity. So now before I go on, right? So I'm going to spend the next 5 minutes trying to make you appreciate what is exactly involved in temporal difference learning. Right? It's going to take a few minutes. So let's start off with the game of tic-tac-toe. Right? And so the goal here is to learn to play the game of tic-tac-toe. I presume everybody knows what tic-tac-toe is, right? And so you play this game and you have to get 3 X's in a row, and the opponent is trying to get 3 O's in a row. And so the way I'm going to structure this is I'm not going to give you any feedback other than the evaluation. So you play the game, right? And the end of it, if you win, I'll give you 1 point. If you lose, I'll give you -1. Right? And if you draw, I'll give you 0 points. Okay? Now the goal is for you to keep playing this game repeatedly and learn how to play it. As opposed to somebody telling you, oh, okay, that guy has put over here, then you should put a X here. Right? So we don't want that kind of a feedback. And you're just going to get a feedback saying whether you won or not. Okay. So before people ask me, hey, why should I learn to play tic-tac-toe this way? This is just an illustrative example, right? I've taken a simple setup so that it's easy for you to follow what's happening. Okay. So let's look at how the game of tic-tac-toe is going to progress. Let's say I have played 1 game, right? So in the game, the boards that I'm seeing are going like this. So now at the end of the game, I know whether I have won or lost, right? So in this case, I have won, right? So then what I do is I go back, I look at all the moves that I made, right? So what were the moves that I made? So I made a move here. So that was the X I put, and then I put an X here, and then I put an X here, and so on and so forth. Right? Look at all the moves that I made. And then I say, hey, all of these moves made me win. Right? So next time I see a position like this, right? Next time I see a position like this, I'm going to make the same move. But I don't want to, commit to that already. I'm just going to say, okay, next time I see a position like this, then I'm more likely to put an X in this corner than somewhere else. Okay? Make sense? And just increasing the probability of putting an X here, because that is something that cost me to win. So I do that for every move that I made in a game that I won. Right? So likewise, what would I do? For every move that in a game that I lost, I will decrease the chances that I will make the same move again. Right? And every game that I drew, I'll just leave it as it is. Is it clear? So if I win a game, I'll increase the chances of playing the moves in the game. If I lose a game, I'll decrease the chances of playing the moves in the game. If I draw the game, I'll leave it as it is. Then it turns out that if you keep playing many games, and then you keep track of these probabilities carefully, you'll actually learn to play a good game of tic-tac-toe. This is actually valid reinforcement learning algorithm. As simple as it sounds, it's a valid reinforcement learning algorithm that allows you to learn tic-tac-toe and other games, other kinds of problems as well. But now I want to ask a question. So how did you know that you win? I mean, you got 3 X's in a row. Okay. So do you need to play this game all the way to the end to know that you have won? Okay. Let's say you come to that position. Okay. You can see that, right? So now I'm going to ask you a question. Let's see. There are just too many buttons here. I'm tempted to play around with those buttons. So I'm going to ask you a question now, right? So I have come to this position that you see on the board, right? And so now I'm going. So do I need to wait, right, till the end of the game to know whether I have won or not? Do I need to wait till the end of the game to know whether I have won or not, right? If I need to wait till the end of the game to know whether I have won, then press true, right? If I need to wait if I don't have to wait till the end of the game, then press false, okay? I presume there are polls on there, yeah. So I'm going to give you the 30 seconds. Okay. Looks like everybody is going to reply, have replied. Yeah, so about 60% of you, I can't read this, numbers are too small. Okay, sorry, that shouldn't be there. About 60% of you said that you don't have to wait till the end of the game, and the remainder said that you have to wait till the end of the game. But if you look at the board position, right? So there is no way Wo can prevent me from getting 3x's in a row. So in this particular game, Wo made a move here, and then X completed by putting a X here. Suppose Wo had stopped X by putting a O here, X would have won by putting an X here. So there's no way Wo can actually stop X from winning, and therefore X is basically 1. I mean, you don't have to wait till the end of the game to know whether X won or not. Right? Great. So then what I can do is, instead of waiting till the end of the game, I can start changing my probabilities as soon as I see this position. Right? I don't have to wait till I get 3x's in a row. As soon as I see a position like this, I can say, hey, this probability has to go up. Putting a X in the top left corner is very good here because it's gotten to me a position from which I know I'm going to win. Correct? Great. So I don't have to wait. And similarly, if I know I'm gotten into a position for which I'm going to lose, then I can always decrease the probabilities. I don't have to wait till the end of the game. Okay. Okay. Here is the next question. Now, this is not a poll. Here's the next question. So how did you know that this was a winning position? Right. You knew this was a winning position because you knew the rules of the game. Right. So you can actually play it out in your head and say that, hey, there's no way Wo can win from here. Right. Because you knew the rules of the game. But then tic-tac-toe is easy. So you might not always know the rules of the game, or there might not be well-written rules of the game, right? In such cases, how do you figure out that something is a winning position? So what you do in such cases is keep track. You remember, you're playing the games again and again, right? You keep track of what led to a win and what led to a loss. You can say that, okay, every time I came to this position, right? Let's say 90% of the times after this, I ended up winning. 10% of the times after this, I ended up losing. Not for this position, but some other position. Right? 90% of the time I ended up winning, 10% I ended up losing. So now, if I go from a position that has, say, 60% chance of winning to a position that has a 90% chance of winning, because of what I have kept track in the past, I know that I'm doing well. So I can already increase the probability of that move. Right? So I don't have to wait till the end. So I'm basically looking at the prediction of winning at time t, and look at the prediction of winning at time t plus 1, and I'm taking the difference. And so if I'm going from 60 to 90, right, then it's a good move. If I'm going from 80 to 40, then it is a bad move. Right? If I'm going from 80% chance of winning to 40% chance of winning, I would consider that as a bad move, and then decrease the probability. This is a very simple idea, right? So this is what is called temporal difference learning, right? So I look at the prediction at time t plus 1, and I look at the prediction at time t, and based on the differences between the two, right, I adjust my behavior, right? I adjust my predictions, I adjust my behavior, and so on and so forth. So not only has this had tremendous impact in AI and machine learning, but it's also had a profound impact in other areas like behavioral psychology, computational neuroscience, operations research, and so on and so forth. So this particular algorithm, the temporal difference algorithm, was proposed back in 1983 by Bartow, Sutton, and Anderson, and I completely fell in love with this whole idea of temporal difference. So I thought, hey, this is something that I can get on board with. This is something that is very, very true for how humans learn. Right? Not so. I mean, there are implementation issues still. I mean, how exactly does the temporal difference algorithm get encoded in the brain? But we see that it's happening, right? We looked at dopamine measurements, and they seem to be predicted very well by a temporal difference tool. So this is something which I got really excited about. And I said, okay, I'm going to spend my career studying this. So I started this in roughly around 1994, and I've been doing it since then. Right? And so I went on. So remember Bartow, Sutton and Anderson were the people who came up with this work. And I did my PhD with Andy Bartow. And that's me with Andy. This is a few years after our PhD, after my PhD, but yeah, Andy was still inspiring, amazing person. And yeah, so I've been really lucky in terms of both my research mentors, Satyakirti and Andy, were not only great people and not only amazingly well known in their fields, but were people who gave me tremendous freedom to do whatever I wanted to do, and that helped me grow as a researcher. Right. So I did my PhD at University of Massachusetts at Amherst, amazing campus as you can see there, but also a great place to do reinforcement learning research. This is the home of RL, right? This is where Andy and Rich Sutton and Chuck Anderson. I mean, Sutton was Andy's first student, and Anderson was Andy Bartow's second student. So this is where they worked when they wrote that RL paper. So my PhD work was on trying to understand what I call abstraction, right? So humans are very good at ignoring information that is irrelevant for what you want to do. So here, let me give you an example. Suppose I have a set of blocks on the table. They have some colors and some labels on them, right? So there are A, B, C, D, E. There are 5 blocks, and they have some colors. Suppose I tell you, get me block B. I don't have to really worry about what the colors of the block are. I just need to look at the labels, right? Oh, block B is here, it's the second from the top, so I need to go fetch it. On the other hand, if I tell you, get me the blue block, right? I don't have to know what is the label on the blue block. In fact, we might not even read the label on the blue block, right? All we will try to do is, okay, hey, the blue block is there below this green one, so let me move the green block and get the blue, right? So it's the same set of blocks, same table, but when I ask you to get me block B, I can ignore the color. When I ask you to get me the blue block, I can ignore the letters. Right? This is a very, very simplified example, but that is the idea behind what I call as abstraction. We are able to ignore information that is irrelevant for the task that you are trying to perform currently. Right? And so humans are very good at forming abstractions. In fact, it's essential for our problem solving skills. If you're paying attention to everything our eyes are seeing and everything our ears are hearing, right, and all the historic knowledge that we have accumulated in our head, right, we will be, just stalled, right? So we will not be able to do any work. We're just processing all this information. So we are able to actually solve problems and actually exist in a world only because we're able to ignore so much of this information. Right, and whatever the example I gave you of ignoring the color and the letters is what sometimes is called spatial abstraction. You ignore some things in the space around you, but there are some things that are called temporal abstraction also. So when I tell you, get me the block, right? I'm not worried about the fact that you have to stretch your hand out and then grasp the block and then lift it and bring it in. I'm just saying, get me the block. I don't think about all the nuances in between, right? So that is what we call as temporal abstraction, right? So humans are very good at doing both spatial and temporal abstraction. So essentially what it means that we can learn all kinds of solutions to complicated problems, right, by looking at a simpler representation, and then we are able to apply these solutions. The utility of these solutions is because we're able to apply it to a similar situation later. Right? I can always fetch any blue block, whether it is called E or whether it is called alpha or whether it is called epsilon. I don't care. I can always pick a blue block, right? So that's the utility of these things. I can apply it to a similar situation. Okay. So my PhD goal was to figure out what exactly is similar, right? And when I put it simply, when I say something is similar, I really am looking at a similarity from a behavioral perspective, right? So if I push something, it will fall. Okay, if I push a bottle, it will fall. If I push the other bottle, it will fall. So these two bottles are similar, right? If one bottle is much heavier than the other, if I push one, it falls. If I push the other, it doesn't. So they are not similar, right? So that's very simply, I'm not going to get into math or anything here, right? Very, very simply put, a similar situation is one which the world behaves similarly. So we needed a behavioral definition of similarity. So mathematically, I introduced something called as an MTP homomorphism, which allows you to model this kind of similarity. So it turns out MTP homomorphisms are actually a very powerful framework and allows us to formalize what we will intuitively have notions like symmetry, right? And translations and things like this. It allows you to formalize a wide variety of this kind of similarity notions that we have in our head. And it was a very powerful tool for building what I call encapsulated solutions, right? So you don't have to worry about the entire world. They can take a small fraction of it, solve it, and then reapply it everywhere else, right? And it has had somewhat of a lasting impact in the community. In fact, as recently as a few months back, people are still citing this work and building on top of it. So that is about my research, and then after that, I came to the greatest institute in India, IIT Madras. I've been with IIT Madras since 2004 as a faculty, and so I was looking for a picture to show that it was not the front gate or the Gajendra Circle with the two elephants, and that's a swanky new academic complex that we have at IIT Madras. So we are not just about the stone elephants. So we have a fantastic research and innovation ecosystem, and all of you know that we are the #1 institute, both in the engineering and overall category for several years now. Right. So here my main research theme has been to what I call look at building complete because they can solve all kinds of problems. Situated, that means they are actually in a domain that they are trying to solve. They are not offline, right? And intelligent because they are solving problems that when a human solves, you would call these intelligent, right? Agents, right? Build complete situated intelligent agents. And towards this direction, I've been studying things like interactions, right? And trying to understand structure of the work, and then all of this leading to more meaningful abstraction. So whatever I started during my PhD days, I've continued, but I've added more complexity to the problem. And so basically my research now spans reinforcement learning and network analytics, which we use for studying interactions as abstraction for studying interactions, is essentially looking at graph models, like that. I mean, so you're not from a computer science background, so that's not going to make much sense, but that's fine. And then natural language processing. But one language is one of the key modalities by which we interact. So naturally, I gravitated towards doing more on language, right? And in recent times, all of this has been overlaid with the latest buzzword, which is deep learning, which is amazing. So this is like coming a full circle, going back to doing neural networks again, but with the complete understanding that neural networks are now an optimization tool, not necessarily biological numbers, right? So that's where I am at, right? So what I wanted to talk a little bit more about in the next few minutes, right? Because I'm talking to specifically to people who are aspiring to go for higher studies or looking at more research jobs, right? So after Kate, what can you do at IIT Madras? Right, so I'm going to say that there are three paths, right? And there's a fourth one which I have here, which is kind of a mixture of these three, right? So you could go to an MTech program, right? Or you could go to an MS program, which is the research-oriented masters, which we have a very strong program in IIT Madras. Or you can go for a direct PhD as well. Right? So you can just skip the master's thing and say, oh, I know that what I want to do is research. Let me get into a direct PhD program. And all of these can be converted to what we call as a dual degree program, dual research degree program. So you could get an MS and a PhD, or an MTech and a PhD, depending on what is the pathway that you come in. And even if you choose to go to a direct PhD, you can always choose to get an MS on the way to the direct PhD. So the last one is essentially a mix of these three. So let me talk a little bit more about each one of these three, right? Okay, before I get into that, I wanted to clarify one thing. A lot of people think that IITs are geared only for undergraduates. So we get fantastic undergraduate, and we produce a lot of undergraduates, and so we in some sense, historically, we have been known for the top undergraduate institutes, but we are no longer an undergraduate institution, right? So look at this pie chart there, right? The blue represents undergrads, red are the masters, and green are the PhD. So the graduate program is much more extensive than the undergraduate program now. So undergraduates still are the same amazing set of people who produce, but we also get amazing set of graduate students as well from IIT. So if you're thinking that we are an undergraduate school, that's not necessarily the case now, just to motivate you with that. So the MTech program, it's a 2-year program. So it's a 2-year program, right? And you do 1 year of coursework, and you do two full semesters for the project work. And in fact, the preparatory work for the project actually even starts in the second semester, right? So you can say that you basically do 2 and a bit of project, but the project work in the second semester is more like a preparatory thing, so that you can go full swing for a whole year into the project. And you do have a lot of opportunity to do industry internships or work on an industry-oriented project. So you can pick whether you want to do an application-oriented project or a research-oriented project. And typically this duration is limited to a year. And many of our students do really well, right? And where do they go from there, right? They get amazing job offers, right? Very lucrative job offers after they graduate from the MTech program. Like I said, they have an option to join a PhD program. They can finish the MTech and join a PhD program, or they can even convert to a dual degree program. And of course, some of our MTechs do go on to do a PhD elsewhere, mostly in outside India. But then another amazing thing, especially at IIT Madras, is that you have a lot of entrepreneurship opportunities. I'll talk a little bit about it after a few slides. I'll get to that. Right? And the MS program is a research-oriented program, right? It's MS by research. So it's nominally usually for 2.5 years, right? And the courses that you do, unlike in the MTech, where you have a fixed curriculum, the courses are typically focused on the research area, right? The set of courses each student does, it depends on the research area of the student, right? And typically, we expect you to produce really high quality publications, right? One or more publications out of this MS by research program. And you also still have an opportunity to work in industry-oriented projects, typically mentored by the projects would be driven by the faculty member you're working with, but you still have an opportunity to work with industry-oriented projects. Right? And the MS students, after they finish, they get very attractive job offers. Often like at the research engineer level positions, not just as programmers, right? But they also get to do more interesting jobs like research engineers. And many of our students go for a PhD, right? And in the US, Europe, and in India. And you could also convert to the dual degree program, like I said earlier. And we are seeing more and more conversions from the MTech and MS program to dual PhD program. And again, a lot of entrepreneurship opportunities. We see many of our MS students actually go out and start companies as well. Right? So talking about the direct PhD and PhD next, the direct PhD is really for outstanding students. I mean, so if you're not in like the top 10% of your graduating class in your university, you should probably go try to come to the MS program and then convert to a PhD or a dual degree program. But if you have an outstanding undergraduate track record, or you're from one of the NITs or IIIT with which IIT Madras has an MOU, you can find this online, where you can apply for your direct PhD interview in the third year itself. So by the time you finish you know that you already have a PhD admit, and you start working on your PhD problem in the final year of your undergrad program as well, right? It's an intense research program, right? Which, in fact, as a PhD student, you'll also get the opportunity to teach, right? Not just do research. And typically, the students here produce many high quality research publications. We expect to see a good impact from them. And the typical duration is between 4 and 5 years. If you're a direct PhD, it typically takes you 5. For a PhD who comes in with a master's is around 4. And again, you get the opportunity to work in industry-oriented projects. There are several programs where you can actually work in foreign universities as well. We have many of these dual programs. We get PhDs from 2 universities and so on and so forth. And many opportunities for PhD students. And what do you do after this, right? So many of the faculty members in the IIT, right, especially in the second and third generation IITs and some in the old IITs and ISC, are PhD students from our programs, right? So from the PhD students from IIT programs. The main motivation for this is you actually get to drive the thought leaders of the next generation, right? So this is just teaching is not just a profession that you do for money, right? Teaching is something that you do because you're passionate and you're making a difference, right? So this is the answer that a teacher should give. Somebody asks, "Hey, how much do you make as a teacher?" The answer should be, "I make a difference," not I make so much money. And again, so you get great job offers, especially in industry research labs. We are finding that more and more of the research labs in India are hiring our own PhD students, and many students go for postdoctoral appointments around the world, right? And finally, we're coming to the entrepreneurship opportunity, which I will start explaining in the next slide. So I'm pretty sure many of you have heard of the IIT Madras Research Park. So here is a picture of the front of the research park, and here is a picture from the inside, and you can see it's pretty looks amazing, and there are a lot of opportunities in the research park as well, right? And so this is India's first university-based research park, and there are several that are coming around that are copying this model and getting inspired by this model and trying to set up something similar. And so we have a very rich entrepreneurship ecosystem in IIT Madras, right? So we have support for people from right from the ideating stage. So we have this Gopal Krishnan Deshpande Center for Innovation. So that essentially, helps you connect with mentors, gives you a little bit of encouragement and small amounts of funding to explore simple ideas, right? And then we have this whole pre-incubation space where you have the Center for Innovation and Nirman, where Center for Innovation is just like a tinkering lab, right? So you have come with an idea, you can try out all kinds of crazy things. Again, the institute gives small amounts of funding, partly sponsored by alumni. Then depending on whether the idea works out or not, then you can move on to the next stage, right? And we even have things like MS by entrepreneurship, and we have an entrepreneurship cell that helps provide many resources. And more importantly, more than just the money and the facilities, there's a rich group of mentors that help students evolve ideas and then grow. Right. And then we come to the entire incubation system. So we have the IIT Madras incubation cell, one of the largest. We incubate about 200 companies a year. And then we have the bio incubator, the biotech incubator. Then we have a medtech incubator. We have RTBI, which is the rural technology business incubator. And so many such thematic incubators and the general incubation cell. And these provide amazing amounts of support. And even after you have the company going, and then we continue to help you connect with mentors and connect with VCs, and we have multiple forums in which you can plug in and so on. So all in all, it's an amazing ecosystem, right? And in fact, it inspires many students who come in without an idea of wanting to become an entrepreneur, kind of change their mind, right, and then go on to try and do something on their own. Right? And I believe that the way forward for India to become a technology superpower is to improve our innovation ecosystem and get more and more people into it. Right? I strongly believe in that, and I'm sure that that's going to get that's going to be driven by initiatives like this, and mostly by people like you. And I think I'm losing a lot of people to lunch. So let me quickly find out. So many of our projects have to do a lot of with societal impact, right? And so there are, I don't know, I don't know how much of you have seen on news, but there is an amazing program on putting out various assistive devices like standing wheelchairs and then completely motorized things that people can move around. This thing on affordable housing. And right now we use this affordable housing. The company that was incubated built a COVID hospital in like a day or so, just using this affordable housing material. Right? And so many of these things that are there. Right? And this is the slide that I had on the international collaborations, but I will not go through that. And I'm not sure if the slides would be shared with people, but if you want, you can drop me a line. I can point you to more things. But we have several joint doctorate programs and joint master's programs with universities around the world. And so when students apply, I mean, they could potentially apply to these programs as well. Right. And we have several things, and I personally direct this center on data science and AI, where all masters and PhD students, everybody works in the center, and you can find out more about the center by going anywhere on the social media and searching for RBC DSI or coming to our webpage. Right. So we run multiple programs, but if you're at the post-GATE level, maybe this is not the right thing. So this is a postdoctoral fellowship, but we also run something called the post-baccalaureate fellowship. So where you're now getting out of your undergrad, but you're not sure whether you want to do research or what you want to do. So this gives you like a 2-year fellowship to work on research problems. No strings attached. After 2 years, you're free to do whatever you want, or you can leave after 1 year as well. So this is, again, I encourage people to explore this. Right? So the goal of IIT Madras that we think we are doing pretty well now, and we want to go much further, is transforming minds. Right? And so we are really great at that. Right? And so here is my two cents on what you should do to prepare for GATE. Right? Before that, you have to make up your mind. Right? There are many paths to success. Just because you do GATE well, or just because you do an MTech, or just because somebody gets a very high score in their undergrad, doesn't mean that that is the only way to succeed. Right? There are people who don't do well, right? I mean, like I said, I mean, I really wanted to get into an IT, but I did get in biology. That's a faculty, but that is not that doesn't mean that that's the only path to success, right? So, but figure out what is the right path for you, and get inspired by that, right? And then once you decide what is the pathway you're going to pick, start preparing systematically. And there are enough material out there. The people tell you what is the right way to prepare, and what to do questions and stuff like that. And I think you should before you fall into one of those buckets and start blindly preparing for it. In fact, I'm sometimes surprised when people say I spent 2 years, 3 years at home preparing for GATE, right? So just make sure that that's really what you're looking for. Because if you're going to spend 3 years of your life preparing for something, 90% of the time you're going to be let down by the outcome. So be very clear as to what is it that you want to do, what are you looking for, and then once you get there, start with that. Right? You will do well and you will excel. Just find the right pathway, and all of you are going to do well. It's not like it's something that is unique to only the small 10% or the cream that's going to do well. Everybody is going to do well in their life. You just have to find the right pathway, right? And if my recommendation, my plea to everybody, so is innovate in India, right? Innovate for India. And if you're successful here, the world will start coming to you. So you don't have to go out and try to be successful elsewhere, right? So that's the thing. I'll stop here, and I'm going to turn on questions if people want to ask questions. I'm not sure if yeah, the questions are on now. Yeah, great. So people can ask questions. I mean, I have some questions that were pre-asked. If there are no interesting questions coming up, then I'll start asking questions. I'll start answering these questions. If we have any questions, I'll just wait for a few minutes for you to post. Can people post questions? Maybe I'll enable chat also. Okay. Anyone wants to chat, not ask a question, you're free to do that. Okay, no questions. Okay, let me then answer some of the questions that were already posted. What is the importance of PhD? Why would you want to do a PhD? Okay, good question. Really good question. Okay. Well, it really depends on what is it that you're looking for, right? And so if you're going to go, yeah, so I'll come to the second question in a minute. So if you're going to go, if you're interested in a research career, right, or if you're interested in a teaching career, the teaching career, you can see, I mean, PhD is kind of become like a qualifying norm, right? So if you're interested in a teaching career, you have to do a PhD. But let's say that, let's take it out of the qualification now. Say, what is it that you're getting up from a PhD that you don't get from a master's, right? So what you can get from a PhD is that it gives you the ability to think about a problem, right, and form solutions. Masters allows you to answer questions, right? The PhD allows you to form questions, and that's a much harder skill to develop. Okay, that's not to say you can't develop that in the industry, but the PhD gives you the time and the space to actually think about it and build it as an explicit skill. While in the industry, you're literally treading water. You're trying not to sink with your every day-to-day work, and you're also going to try to pick up this other skills on the side, right? While in the PhD, that's basically what you're being trained for asking questions. Right. And I think you will get a lot more from a 4 years of PhD in terms of preparing you for a research career than you can get for 4 years of doing a research engineer job in the industry. Right. So having said that, that's the general prediction. So there are always exceptions to this. There are some people who do go to the industry after a master's or even after undergrad and are extremely successful there. But by and large, it's a much easier pathway if you do a PhD. And I mean, there is no one size fits all answer to how do we decide what is the right path for you. I mean, it depends. So if you're confused about multiple choices, then I would encourage you to find out more about each, right? I mean, maybe spend a little bit of time and try to make up your mind, or talk to people who are already in that space and so on and so forth. But you just know at some point. Right? I'm sorry, I can't give you a much more satisfactory answer than this, but it's a very uniquely personal thing. Right? So in my case, I mean, I knew from when I was like 5 years old or something that I want to be a teacher. So I'm just surrounded by teachers. So that was never a question that I had to wrangle with. But it's a personal thing, so you have to look around for answers, right? Yeah, so AI is something that is all pervading now, right? So in fact, we at IIT Madras, we have something called a 5-year dual degree program in data science, which teaches you, which essentially allows you to earn a bachelor's in any branch of engineering and a master's in data science and AI, right? And in fact, a large fraction of the people who come into that program are mechanical engineers and then chemical engineers, right? So they get a BTech in mechanical engineering and a BTech in chemical engineering, and then they do a master's in data science and AI. So there are a lot of opportunities, especially in the manufacturing sector, right? A lot of opportunities for mechanical engineers, things that typically you would expect a production engineer to do. There's a lot of scope for AI there, right? And automation, again, a lot of scope for AI. So there's a lot of scope, and even in design, right? So in fact, I have done a project for the vehicle design divisions of automotive companies, where we try to use AI in the vehicle design space, right? So mechanical engineering, there's a lot of opportunities for AI. I mean, every branch you take, there's a lot of opportunities for AI. We are now working with chemists, people chemistry researchers, trying to come up with AI for molecule design, right? So everything, right? Everywhere it's possible to do AI, right? So RL is very much part of artificial intelligence, right? So it's a specific way of learning, right? So it's very much part of artificial intelligence. I mean, there are many online resources there, so you can look at it. I mean, my own course on reinforcement learning is online, and I also have a small tutorial on like a 1.5 hour tutorial in RL if you don't want to do a 10-week course on reinforcement learning. That's also there. But apart from that, there's a whole bunch of other material online. In fact, Andy Barto and Rich Sutton have written a textbook, which is freely available online. So there's a whole bunch of things that you could do. No, postdoctoral means you need to have a PhD, right? It's after the PhD fellowship, but we have a post-baccalaureate fellowship, which is after a bachelor's, right? So you could apply for the post-baccalaureate fellowship, right? So look up the online. So we have an advertisement, everything that's there online. Just go to the rbcdci.iitm.ac.in page, and you can find out more about it. Right? And there's one other question that I want to add. So, how to start my journey in AI? Can you give a kickstart or roadmap? So there are two things. So you need to know something about AI, right? So I would recommend either Andrew Ng's, as many people call him Andrew NG, Andrew Ng's course on Coursera. It gives you a very basic introduction. Don't tell me that you know AI after you go through his course, but it gets you started, right? And then you have to get your hands dirty. So I would recommend going to Kaggle, going through some of Kaggle's tutorials on how to start solving problems and things like that, and then playing around with some of the data sets and some of the competitions that are there. And you might not win the competitions or anything. This is more for you to learn, right? So, but if you win, great. I mean, I'm not saying you can't, but if you win, that's great. But it's more for you to learn. So get your hands dirty, and then you can start from there. So, yeah. So that would be my recommendation. Let me answer one of the questions that were there already in the slide, and then maybe we can end there, right? So I want to, well, maybe let me take the first two questions, right? The rapid pace of advances in AI, can it pose a potential threat to employment as machines can easily take over manual tasks? So any transformative technology, right, changes the employment landscape. So I'm not sure how many of you might even remember something called STD booths. Right? There used to be telephone booths which had an operator who will sit there and help you make phone calls, or that you go there, you stand in a queue, long queue, and then you go in and make a phone call. And whenever I was in college, we used to go there and stand late in the nights because there was this concessional calling rates around 11 p.m. or something. So there is this whole ecosystem, ecology built around this connectivity, right? Just telephone connectivity. Now all this is gone, right? So everybody uses their phone, right? So nobody is like standing in long queues and things like this. Whole ecosystem that just got completely destroyed, right? And similarly, I mean, when I was in school, I mean, all of us learned typing, right? So that was considered an essential skill. Just like at some point, learning word processing was considered an essential skill. Before that, learning typing was considered essential skill. Everybody went. I mean, I went to a typewriting institute and learned to type. Right? Not just. I mean, it's not just somebody learning to type and jobs, right? There's a whole ecosystem around it. A lot of romantic novels written about people meeting in typewriting institutes and so on and so forth. This is completely gone, right? Not just did it transform the employment landscape, right? The whole societal landscape got transformed, right? And so whenever the technology comes, that is going to be a change. So AI is going to cause change. I'm not going to say AI is not going to take away some jobs, right? But then there is a whole set of other opportunities, other jobs that AI will create. I mean, it's not that BPO was not a job description I would have just imagined 15 years ago, right, or 20 years ago. But now a lot of people work in the BPO industry. Right? So like that, there is going to be newer and newer opportunities that are created by the advances in AI, right? And so there will be a shift. You might have to do some kind of reskilling, and you guys are in a great position, right? You can choose how you want to take your career forward. But even for people who are already in the industry, it's going to take some amount of reskilling. But there will be different jobs, maybe more jobs that need more intellectual capital. It's going to happen. And finally, I'll take this question. What are your views on GPT-3? Yes. Okay. Before that, I think there's a more interesting question for more of immediate urgency. Uh, um, Government jobs in AI. So the government is investing crazily into AI, right? So every branch of the government is now going to invest in AI, whether it is the Ministry of Statistics or Health or Agriculture or Transportation. Everybody, everybody is investing crazily in AI. So there's going to be a lot of scope even for government engineering jobs for people who know AI. In fact, a lot of these people are being sent to universities like ours. In fact, we work with the government a lot. We do for training for DRDO scientists, getting them more up to speed on AI from different verticals. It's not just we take the guys from the AI lab in DRDO and teach them more AI. I mean, we also talked about other people. We are now training naval officers in AI, right? These are guys who work in the naval research labs or in the naval training colleges. They are coming to us and learning about AI, right? So it doesn't matter which sector it is. The government is spending a lot, and you're going to find a lot more opportunities if you know AI in the government than not. Yeah, and I mean, you can Google me, you can find me online. So Balaram and Ravindran IIT Madras. And so the question was, how can I contact you? You can just send me an email. I'll try to reply. I do get a lot of emails, but I'll try to reply as much as possible. Oh my God. Okay, it's the same question repeated multiple times in some kind of a glitch. Okay, so GPT-3. So somebody who asked this has been keeping up with the AI news and stuff like that. So what is GPT-3? So GPT-3 is a new neural network deep learning based program that's been put out that is generating what many believe to be very human-like language. And if you train it properly, it can even generate SQL queries for you. And I mean, it does a whole set of amazing things. Right? So that's what everybody thinks like, oh, GPT-3 has solved the AI problem. Right? That's not the case. Right? So GPT-3 is still a statistical model. Right? It doesn't understand language. Right? It is not solving AI. It is just spewing out language similar to what it thinks already exists. And it doesn't know that the language it spews out more often than not is very offensive, right? Very racially divisive, very abusive. It doesn't even know that. It just says, okay, this is the kind of data that I was shown earlier. I'm just going to spit out something very similar, right? So it doesn't understand the content of what it is producing. So my views on GPT-3 is it's a great tool, right? Use it like you would use any other tool. Know what is it's good at, know what it is bad at. It is not replacing a human being in terms of generating language. You have to monitor it, you have to mentor it, quote unquote, right? Make sure it produces the right kind of output. Right? So that's my view on GPT-3. Is there anything else that is interesting that I can try and answer? Well, how many electrical? There's a question here, sir. AI is to be done in software programming. So what about in electrical engineering or mechanical engineering? Okay, let me ask you this question: how many electrical engineers or mechanical engineers out there who don't know programming? Right? Everybody does programming at least through some kind of tool usage, right? So whether it is a CAD tool or whatever, right? So you do use computers. So AI has come to a point where people who are doing CAD design want to use AI. They can just add a few more drop-down boxes and then connect things up, and then you can then have AI in it, right? So that's one part of it. The second part of it is you don't have to build the solution end to end. Right? So if you understand enough AI to know that, hey, this is a problem that I have in my situation, which can benefit from AI, that is great, right? Then you can call somebody who knows AI and tell him, okay, just solve this piece of the puzzle for me. So, So in the modern day development, it's teams that work, right? It's not an individual. So that is one part of it. But yeah, it is software driven, and but enough software is already percolated into all branches of engineering. So I would be very surprised if somebody says, "Oh, I don't know how to use software, but I'm a mechanical engineer." But I think you should be able to do that, and everybody should. Now, not just engineers, right? I would say that everybody, like accountants, doctors, in any profession that you are in there, right? So you should know how AI is impacting it, because AI is going to impact you whether you want it or not. Whether you are using it or not, somebody else is going to use it, and you are going to get impacted. So you should know what is the impact, what is the potential impact of AI on your life. So you should learn AI, right? Yeah. So I think we are done. I think we have reached the 1 hour mark as well. So it has been great talking to you guys. Unfortunately, we couldn't do this face to face. Love the energy that comes from the students as well. But unfortunately, seems to be the new normal, and we have to get used to it. So thank you, everyone, and good day. But stay safe, stay socially distanced, wear masks, sanitize everything, and yeah. So then we can all start meeting face to face soon.